Thank you very much. So, the last session of the day, I have enjoyed a lot this JNation. This is our first time here. So, Maven puzzlers, I'm Ixchel Ruiz.
I'm Andres Almiray, and first I would like to say, boa tarde, Coimbra. Are you fine? You guys have coffee? Do you guys have fun this year's JNation? We're back.
Okay. Andres tried in Portuguese, but
terrible.
I think it's easier in buenas tardes. Y
Hola.
ahorita se van a dar cuenta por qué. Espero que me entiendan. Yo también entiendo portugués, pero pues mi portugués no es ni remotamente bueno. Entonces, Maven puzzlers. And my name is Ixchel Ruiz. I'm from Mexico. That's why I started in Spanish. I live in Switzerland. I'm a Java champion. I work for JFrog. And I participate in a lot of open source foundations. For example, the CDF, the CNCF, the OpenSSF. And I have collaborated in 2 books. The latest one was DevOps Tools for Java Developers. And this is Andres.
So I'm Andres. I'm also coming from Mexico, so I do speak very bad Spanish. And I also love open source. We both together live in Switzerland. We've been working in open source for quite a while. And one of the things that we like to do is travel the world and talk about our experiences with building software, both commercial and open source. And so that's why we are very, very happy to be here with all of you to be able to share this knowledge.
And as Andres says, we work a lot with open source. And one of the things that I like to talk about is, well, there's 3 things I love to talk about. Actually 4, but anyway. So it is testing, it is security, it is tool, and it's about community. This session, it's about tool. And I think one of the most important tools. Because as developers, we have to learn a lot of tools. And when we learn them correctly, or we know the small details about each one of them, we can have a better life, developer happiness. So let's talk about tools and one of the most important build tools out there. And we're going to say that it's one of the most important tools out there because it's still the most, for example, in my company, we tracked a lot of the repositories, even open or closed source, and it is still one of the most popular type of repositories. And for example, even after this developer productivity report for 2023 of JRebel, it's still stating that Maven is the most used build tool out there. And this one, it's coming from IntelliJ idea. Well, yes.
JetBrains.
JetBrains. And it also, they show that 73% of the projects out there use Maven. So whenever you see the QR code, you can scan it. The slides are going to be available, so don't worry about that. But you can find all the sites there. So we're going to talk about Apache Maven.
So quickly, a few show of hands. Who uses Maven as your main build tool? See, so for those watching the video, close to 70% of you raise your hand. And that's the thing. Even if Maven is not your main build tool, you still will have to consume the POM format, which is what Maven uses for defining the build. Whether you use Gradle, SVT, Lineagen, or the other popular Java build tools, we all use the POM format to resolve dependencies. So we have to know how to work around and how to pretty much consume the POM XML file, regardless if Maven is our main build tool of choice or not.
Because for the people that didn't raise their hand, they're probably using another one, as Andres mentioned, maybe Gradle. But if I ask them the question, like, do you use Spring Boot? Do you use Quarkus? Do you use any other one? And the chances are they're going to say yes. So by saying yes, they are still consumers. So it is important that we all understand what are some of the rules about Maven. So this is the side of Maven. So Andres, are you ready to talk about jars?
Yes, jars, but actually Java archives, not those jars. I love jars, I love marmalade, but it's a different thing.
Okay, so for the people that were in my previous session, I like to talk about dependencies. And dependencies are, first of all, not the same. And even when they are the same, when we are facing dependency resolution, this is actually some of our expressions. There is a reason why we call the dependency resolution hell.
Yeah, the class path hell, whenever we're working with Maven.
And it is something that we have faced one time or another. Class not found exception. During runtime, something breaks up because we are not using the version that we expected to be using.
Or the wrong method signature is used because the class that was loaded was not the correct one because the version that was found was the wrong one.
Or I'm adding a jar without even a version because who needs version?
Yeah, who cares about versioning, right?
So these are things that had happened to us in the past. So we are not talking about hypotheticals here. We're talking about things that can happen and that had happened.
Almost every single day.
Yes. But before we continue, I have a question for you. So when you join a new project and you do a Git clone in case you're using Git, and you check out a Maven project, what is the first command that you execute? Maven clean install?
No. Please stop doing that.
Well, Andres here, I'm not going to let him talk about it because we can fool this hour with Andres rants about Maven clean install and what are the negative things about it. I will suggest you to use Maven verify. Most of the times it's going to work, and we will explain why most of the times it's going to work without bashing Maven clean install.
So as you probably are aware, Maven works in a very linear way. It's called the lifecycle phases. It starts with a particular phase and goes through all the different phases until it reaches the end. That goes through the sequence. The typical sequence that we go through when we say Maven clean install is actually two different sequences. The first one is clean, which is very short. And the next one, you see from the start, we see validate, and then there's some gray ones which are smaller phases, compile, everybody knows that, and test, and package. And over the top, you see there's one called verify, and the next one after verify is install. Pretty much every time that you do install, you are also invoking the verify phase intrinsically. What the verify phase performs is just everything from the start up to that point. And what the install phase does is take everything that was built on the jars, zip files, POM files, every artifact, and publish it into a Maven local repository. That's the last step. If you are building a project and you don't need to publish those snapshots or those artifacts, then there's no need to call install. I/O, disk I/O is slow, even if you use an SSD, if you do it so often. So don't push things into Maven local if you don't really need it. Just invoke verify. There might be cases where you will need to push or publish artifacts to Maven local for a particular test case or a plugin or something else to work. But I can guarantee you that 90% of the cases, you should be fine by just doing Maven verify. And that's my rant.
Okay, so we're going to talk about dependencies. And when we're talking about dependency resolution, we have this dependency graph, at least in our minds. And tools like Gradle and Maven are creating something like this. And if we're using the same version in all our different libraries, in transient and direct dependencies, then there is not a problem. We should have this session. But what is happening is that sometimes we're using a particular dependency with almost the same coordinates.
Just imagine this red dot here is Log4j version 1.214, which you should know that is broken. And this other version is Log4j 1.217, which is fixed. So the problem with this particular graph is we have two versions of Log4j, and depending on the resolution rules, the wrong one will be selected, and we don't want that.
Yes. So this presentation is a little bit different because we will ask you to take out your phones.
Yes, you're highly encouraged to take out your phone right now and scan this particular QR code that will open a website called Mentimeter, which contains a series of questions as a quiz. And so we'll try to make this as interactive as possible.
Okay. So people are there. So these are trial questions. So how do you install Maven? Homebrew, SDK man, like you download and do it manually. How do you do it? Okay, we have people in the audience that use SDK man, and I'm so happy. I'm so happy because for the people that do not know about SDK man, it is an amazing tool. It's actually, it's going to let you, for example, if you're using Java, which I probably, we are all doing, with SDK man, you can install different versions, and not only that, run different versions of Java in different terminals.
Right. So for those that have chosen manually, it's okay. But the thing is that you have to find the zip file at some location and download it, unpack it, configure the environmental variable, off you go. And follow the same steps every time that you want to upgrade or downgrade a version. What a package manager does is perform these functions automatically for you. And some of them, like SDK man, will allow you to have concurrent versions or different versions and switch between one another very easily. So our recommendation is select a package manager that works for your current environment, and our personal favorite will be SDK man.
Okay, let's continue. What version of Maven do you use?
There are quite a good number of versions out there. The latest version for Maven 4, which is not yet final, is 4.0.0 Alpha 5, published in March of this year. Maven 3.9.2 came out, I think, no more than 2 weeks ago. 3.8.8 came out also mid-March, and that is kind of like the stable version. 3.9 is a little bit more like a modern version. And 3.6.3 was very common. It was released, I want to say, a bit more than 2 years ago. And if you're using older versions of Maven, what are you doing with your life? I understand that companies move slowly in some cases. If it's not broken, why fix it? But in the case of older versions of Maven, they're quite broken with security. So if you are not using Maven 3.9 or 3.8, if you're using older versions of that, I urge you, I encourage you to upgrade as soon as possible.
Okay, do you use a Maven wrapper? And you're having so much fun, guys. People.
Do you know what the Maven wrapper is? Yes. So, yeah, kind of. We're in a little bit in the middle. So the Maven wrapper is a script that allows you to bootstrap a particular version of Maven. The great thing about this is a feature that came out from the Gradle space. So if you are in a local environment or on CI, you need to use a version of Maven. If that installation of Maven is not there yet ready for that system, then you cannot build. What the wrapper does is provision, download a particular version of Maven that you define so that you can run your build. And this works both in your local environment or on CI. In the past, In the early days of CI, we used to just call this the IT department and say, hey, can you do me a favor and provision this version of Maven on such and such nodes? And like 3 months later, they will come back, yeah, I did it, but it's actually the wrong version. Well, guess what? With Maven Wrapper, you can provision the right version for your project in a snap.
And even you can use a private URL. You can create your own version and point it to that one. So, do you use the Maven daemon?
Do you know what the Maven daemon is?
Okay, every single time that you execute a Maven command, what happens is a JVM, it's a start. And then you execute the invoked command, and then we do magic, and then the JVM shuts down.
Yeah, we just killed it.
So the daemon is there because it's going to create a JVM, it's going to start it, it's going to execute the command that we have invoked, and it's going to go into the background. For the next time we actually invoke a new command, it's going to go into the foreground, and we're not going to pay twice the price of starting a JVM.
So basically, you are invoking JVM processes one after another and making sure that the second, the third, and the subsequent processes are much faster because you have a JVM already warm in the background.
So now we're going to start with the real questions. So when we say that this is correct or the result, it's because we're going to execute Maven dependency tree. And so let's start.
Just go back quickly to that one, to the previous one, because there's another question here. Question here, what are we invoking here? Are we invoking a lifecycle phase, or are we invoking a plugin go? Who says lifecycle phase like compile or package? No hands? Who says plugin go? Yeah, that's the correct thing. And there is a difference. Whenever we do this, we are not invoking a lifecycle phase in any case. So whichever plugin and go reacts to that command is the only one that is going to do the work. Whereas when we say clean, install, compile, package, there may be more than one plugin that can do work.
Okay, so you already are starting to answer. So this is the most simple POM file that you can see there. You see that we are in our dependency block. We're declaring two versions of the same dependency, Google Guava. In one, we said version 27, and the other one, we said version 28. So what is this? Is this going to be a build error? Is it going to be chosen 27, 28?
By the way, we are not just speaking on Guava because I hate Guava. This will happen for any kind of dependency that has duplicate versions. It's just that Guava is so prevalent. Everybody finds it in the POM files that we just selected. And for this particular question, this is the only one that has a little bit of a trick because it's dependent on the version of Maven that you're using.
Yep. So when I saw this example, I said it has to be build error. Because for crying out loud, I'm not making my mind up. How can I be saying use the two of them at the same time?
Okay, so let's see the answers. Let's see how we did.
So the right answer is version 28.
Okay, so for those of you that answer build error, please raise your hand. Keep it up if you're using Maven 4. Yeah, that's what I thought. This is a build error in Maven 4 because clearly having duplicate versions of the same dependency should be an error. But if you're using Maven 3, this is a warning.
Okay, so, it's version...
But also, notice that the version number that is selected is version 28. Now, those that selected 28 might think, haha, I know, 28 is bigger than 27. I know my numbers, I know semantic versioning. But guess what? Version 28 was not selected because it's the latest.
So it's not semantic versioning. Maven doesn't care about that by itself. So why was it selected? Because it was the last entry on the file.
So here's another thing. If you were to invert the definition and put 28 first in the POM file and 27 second, 27 will be the selected version.
Okay, so for those that say, Ixchel, this is inconsistent, I hear you. So if you want that to be a problem, we actually suggest you to use the Maven Enforcer plugin. This is going to be our answer for most of our questions.
Right, so if there's anything that you take home today from this session, there is only one thing, is give a try to the Maven Enforcer plugin if you have it. I guarantee you it's going to break your build, and that's what you want. Because I'm pretty sure that your builds have some issues that we may not be aware of, and this thing will bubble up to the surface, so now you have visibility on them and figure out a way to fix them.
There's a lot of rules that you can select. So the first rule that we're going to see is exactly to solve this problem.
Ban duplicate POM dependency versions. A very specific rule that says if whenever you find more than 2 explicit dependencies, so say different versions for the same group at the artifact ID, this is clearly an error. So we upgrade that warning into an error. So if you're using Maven 3 today, add the Maven Enforcer plugin, configure that rule, and now you'll be able to tell if there's some error.
Okay, so let's go back to the questions. In this new one, oh my God.
So where's the code?
I don't know. Let's see. Okay.
Oh, there it is.
No, but this is the question. This is the question, yeah. So in this particular code, now we have, in the direct dependencies segment, we have version 28, and we also have Google Truth version 113. And one important thing that you have to consider is that actually Google Truth has as a transient dependency Google Guava.
So we have a direct dependency. So if you look at the resolved dependency graph, from our point of view, from the POM, there is a direct dependency Guava, and there is truth. Both of them are the same distance from the consumer, right? And now here in Google Truth, we have one level down, we have another version of Guava. So if you resolve the thing, you have 2 different versions of Guava at different locations.
So Google Truth is going to bring Guava 30.1.1 Android. So at the end of the day, which one is going to be the one used? And you're right. It is going to be version 28.
So for those of you that selected build error, no, this actually works. And I know that in the previous example, we said that the last dependency that was defined will win over. But in this case, the direct dependency is the one that wins over.
Okay, so let's continue. Not to that one, but to the slides.
Yeah, so there's a way that we can fix this, again, using our friend, the Enforcer plugin.
So now it's about semantic versioning. We already told you that Maven doesn't care about semantic versioning, and when we first started looking into it, we actually were surprised. So Andres asked Robert Schulte, who was the PMC of Maven at the time.
He was the leader of the Maven project at the time.
And so what we learned is the semantic version is not taken into account. But if you want that, you can use this particular Maven.
So we humans, we understand semantic versioning and we can follow the rules. But Maven, the tool, has no clue whatsoever about semantic versioning. I mean, from the core. But if we apply the Enforcer plugin, then we can instruct and tell Maven, hey, there's this thing called the Maven semantic versioning. What would be a cool idea if you use it? So we have a couple of rules. The first one was, can you go back to, I think the name of that one is dependency conversions. And this actually, when you see, it says, oh, hold on a second. Even though we knew there were 2 different versions of Guava, it actually evaluates the whole graph. And Guava has additional dependencies, and all of them were different. Here we're looking at all the different things that are happening. Why is this a problem? Because depending on the class part order, you might load one class or another class, which this one will have a different set of methods than this other, and that's when trouble arises. So it's better to reduce the amount of different versions that we have in our dependency resolution graph and have just one single version. That is dependency convergence.
Now, if you want something similar to the upper bound depths,
Semantic versioning, this is what you need to configure. They require upper bound depths. And in this case, for example, you can actually, there is an error, and it's actually telling you, we have a problem with the different versions of the dependencies that you are bringing, either direct or transient. Right, so two different versions, and in this case it's saying, hey, look, if I follow semantic versioning, version 3.30.1.1 Android looks like it's the latest one, so go with that one.
So let's go back to the questions. Okay. Oh my God. I'm using both screens. Oh, okay.
There we go. All right.
So now we have the dependency management block.
Who knows about the dependency management block? A few hands.
Perfect.
Okay, you're at a good spot.
So we are saying the dependency management block, version 27. In the dependency block, we set Google Truth with version 1.1.3. And again, Google Truth, it's bringing version 30.1.1. So what is going to happen? We don't have a direct dependency here. The last one, it is Google Truth that is bringing a transient dependency, and the transient dependency is 30.
Okay, so 72% of you chose the right answer. And this is because the dependency management block works like if it were a lookup table. So whenever Maven encounters a dependency that matches the group ID and the active ID of something defined in the dependency management block, it will assign the corresponding version. So in our case, that will be version 27.0 JRE of Guava. No matter where in the graph is found, that version is going to be chosen as long as there is no explicit version defined anywhere else. Because true defines a transitive dependency with no explicit version that we can see in our POM files. That's why version 27 wins.
Okay, a slightly different example. Now, we have in the dependency management block, again, 27, in the dependency blocks, 28, and the transient dependency. So who is going to win? Remember, Google Truth brings 30.1.1.
So it's a little bit close, but I can't, wow, 27 started to win over, interesting. It turns out that 53% of you are correct, because remember I just mentioned, the dependency management block will determine which version is going to be used as long as there is no explicit version used anywhere else. Here, we have an explicit version, 28, and that is why that one wins.
Direct dependencies, explicit direct dependencies will always win. It doesn't matter what you have in the dependency management block. Okay, let's continue. Okay, so now we're going to do a slightly different thing. In this case, we're going to have two dependencies that are going to have a transient dependency at the same level. So that's the added complexity.
The important thing is that they are at the same level.
Yes. So this is the point. In the dependency block, I have use 5.1 and truth 1.1.3. And this is the key here. Truth brings 30, use brings 30 Android, the other one brings only 30. So which one is going to win? Again, two direct dependencies, but each are bringing a transient dependency. So the last entry in the file is truth 1.1.3, and truth 1.1.3 is 30 Android. Okay, So
it wasn't even matched at the beginning, but then, is there something going on here? Recall from the first question.
So remember when I said it was the last entry in the file? Yeah? I also remember it. That only works for direct dependencies.
Because when it comes to transitive dependencies,
it's
the first one that is found at the closest level wins.
So it's the first one. So watch it. Watch it. Okay, next question. I have the dependency management, WABA 28, and now I have Google Truth and use. So it's almost the same example, but now I'm adding a dependency management block. So what is going to happen? Yes.
Okay.
Because it's a transient dependency, then now we're going to use the dependency management block. Because there I don't have any direct dependency, so that is correct. I'm really, really happy about that.
Okay. So this covers the first section. So we have 2 more sections. We're going to be more quickly. And that so far, we just cover a single POM file. Things are easy when you just have to deal with just one thing of something. What happens when we add more? What happens when these more things have some sort of relationship? In this case, it's a hierarchy. We have children files or POM files, and we have parent files.
So we have this parent POM, and it's the parent POM we have a dependency block selecting 28 or specifying 28. In the consumer POM, or the children or the child, we are importing the parent POM over there, and we are actually only declaring a dependency which is going to bring WABA as a transient dependency. So what version are we going to have? Are we going to care about our parent dependency, or are we going to care about our transient dependency? Who's winning?
Okay, so close to 60% of you say the version from the parent, and this is the reason why. Every single Maven POM file, when evaluated by Maven, has a parent, whether you define it or not. If that parent that you do not define is known as the Maven Super POM, and this is the one that defines the basic behavior that you can have in a project.
So this is going to be about effective POM resolution. Ixchel, what is effective POM resolution? So, I have a better question. Andres, what is an effective POM resolution?
Okay, so what we write as developers is just this POM or that POM. We're not writing the effective POM. What happens is the following. So based on the child, when you tell Maven, hey, let's work with this project and let's do some sort of resolution, Maven reads that POM file and says, oh, you have a section called parent. And I look at those coordinates and find the parent POM. So now I move into the parent POM and parse it. I see the definition of my parent POM, and there's nothing more than just a explicit dependency. But Maven knows that there is yet another parent POM, which is the super POM. So it comes into the super POM and looks around and says, well, you only have some plugin definitions, there's nothing more, so I'm going to grab that and put it into a particular place which is called the effective POM. So now I have everything from the super POM, comes back into the parent and sees that it has some Maven coordinates and explicit definition of dependency, so puts that there, and then goes into the child, looks that it has already resolved the parent, and continues the resolution, and what it does, he sees some Maven coordinates from the child, and some dependencies. So when you look at the effective POM, we have to look at the resolution of everything that came before the child, and everything is put in one place. So we end up in the effective POM as if we have one explicit dependency here and another explicit dependency for truth with guava as a transitive. We have seen this case before, remember?
Yes. And what did we said? Direct dependencies always win. Okay, next example. Let's go fast. So in that case, we have a dependency management block on the parent. We have a dependency block too, so 26, 28, and a transient dependency on the child. So which version is going to be resolved? 28, 20, what are the options?
Yeah, 28,
It's
26,
26,
or 30.
28, or the transient. Well, we know that the transient is not going to be. So Android, it's not going to be.
So just remember, following the resolution of the parent hierarchy, in the end, we have an effective POM that has a dependency management block, a direct dependency, and a transitive dependency. We know that there is an explicit direct dependency that is going to win over, and that turns out to be version 28.
Direct dependencies always win. Okay, next question. Parent POM, dependency management, 26, consumer dependency with a transient.
I guess by now you should be able to know how the effective POM will be resolved. So I'm happy to see that pretty much 80% of you got it right. Perfect. So
Actually, the trick in that trick question was that we already gave the answer in the previous one. But this is a different scenario. So now we have in the dependency management of the parent 26, in the dependency management of the child, we have 28 and a transient dependency.
So we have two dependency management blocks.
So in the dependency management block, we have 26 or 28. So what's going to happen? Is it an error? It is going to be the parent. It is going to be the children. We know that the transient dependency already lost that battle. He doesn't count, or it doesn't count.
This is not a build error. This actually works. And what happens if you follow the resolution of the hierarchy, the dependency management block of the parent will be overwritten by the dependency management block of the child. So whatever the child says there is going to be the selection. So in this case, is version 28.
Now we're going to see the third most used way of POMs or bombs. In this case, is the bomb.
This is the last series of questions. So do you know what a BOM is, a bill of materials?
Not the software build of materials that I was talking about. This is something different. And for example, if you're using Spring Boot, if you're using Quarkus, you're already using them. Because when you import a new dependency, you usually have a single entry. But for example, all these frameworks or all these libraries already have also dependencies, and they know which versions work well in their projects.
Right. For example, a very popular BOM file will be JUnit, which provides the dependencies or a list of all the dependencies from the JUnit project. There's also Jackson that contains all the dependencies for the Jackson project. But if you're using Spring or Quarkus, you might have seen something called Spring dependencies or Quarkus Universe BOM or something like this. These are BOM files that provide every single project from Quarkus or Spring plus additional dependencies required for an application to work. So from the point of view of JUnit and Jackson, I will call these BOM files as library BOMs because they only provide information about the projects that belong to that particular meta project, if you will. Whereas in the case of Quarkus and Spring and Helidon and the others, these I will call stack BOMs because they provide all the different dependencies that you need in order to build an application that follows a particular set of conventions. So regardless of you using a library BOM or a stack BOM, BOM files are consumed in the same way.
And they look exactly like this. As you see, they are very similar to the previous case. But in this case, if you looked at the type and the scope and the artifact ID, it's a little bit different.
So the important thing about a BOM file, which is what we see here on the left side, is the dependency management block. This is the most important thing about a BOM file. And how we consume them, we have to define the Maven coordinates for a BOM file inside a dependency management block, plus two additional XML elements that Ixchel mentioned. The first one is use the import scope, and the second one is that we have to change the type to a POM, because look at the packaging XML element that the BOM file has. It is POM as well. Why? Because a BOM is just a collection of dependencies. In itself, it does not have an associated jar file. So we tell Maven that this is just a metadata file. There is no binary related to it. Why? That's the reason why we have to use packaging POM.
Okay, so in this case, remember, the most important thing in the BOM files is going to be the dependency management block. And in this dependency management block, we're established version 28. And in the consumer, we have two transient dependencies. So which one is going to win? And I'm happy to report that most of you know it. It's going to be the 28 because it's declared already in the dependency management resolution block.
So what we're doing when we're importing a BOM is like we're looking into the dependency management block of that BOM file, and we copy it over into the consumer. This is why BOM files have become so popular nowadays, because BOM files increase reuse. We can define some common dependencies that go together for whatever reason the creators of the BOM file had deemed so, and when we consume them, we are safe in the know that those dependencies are working together because whoever created that BOM file has done the appropriate testing. So when we consume them, we can be safe in saying, yes, I simply grab everything that this is suggesting so that I can do my work. And you can import as many BOM files as you want, but be careful about the order of importing.
Yes, that is going to be very, very important. So in this example, we have in the BOM file, in the dependency management block 26, as a direct dependencies 28. In our dependency management, we are adding the BOM file, and we have a transient dependency. So what is going to be the version result? And it's going to be 26. Why?
Why is that the case? Didn't we say that explicit dependencies win over? Yes, but we also said that the most important block in a BOM file is the dependency management.
So that direct dependency is not taken into consideration.
Whoever consumes this BOM file only looks at the dependency management block. Anything else is completely hidden from view, as it didn't exist. So that's why the version that we import for the BOM continues to win over.
Okay, next question. So again, we have a BOM, we're importing it, but we have in our dependency management on the child version 26. And on the BOM, we have version 28 and a transient dependency, but we already know that transient dependency always loses. So the question is 26 or 28? Or what is going to happen?
Okay, interesting results, but actually 26 wins over because it's an explicit dependency within the dependency management block. So even though we are reaching out into the BOM file that says 28, and when we put it here in the consumer, we have version 28 and version 26. If I put 26 before the importing, it will still win over for the same reason, because it's an explicit dependency.
So, as you can see, it is a little bit confusing.
So this is the last question.
Now, final example. My final question, final example. We have in the dependency management of the BOM 26, in the child, we have in the dependency block 28 and a transient dependency. So which is going to win? Why?
Why does 28 wins over? Because it's a direct explicit dependency. Once again, as long as we have an explicit dependency, and in this case it's even direct, it's much, much closer than everything else that is coming or importing from some other place. So this is why it wins over.
Okay, all the questions are available in that particular repository. So if you want to test them or run them with the different versions of Maven and see, even configure different Maven enforcer plugins, you are more than happy to do that. The slides are going to also be available online, and also the results. So I hope that you saw that there are some really conflicting rules about dependency resolution in Maven. Like, if, for example, if you have direct dependencies and you are using still Maven 3, the order that they are going to be listed in the file does matter. Like, it's going to be the last one. But if you're talking about transient dependencies or in the dependency management block, it's going to be the first one. So honestly, if you want to remove all that kind of uncertainty, because honestly, you depending on in what order you define an entry in a POM file, and somebody is going into your POM file editing without knowing the expected rules that you have in your mind, that can result in some problems. So please do the Maven Enforcer plugin with the different rules that are available.
There are two more additional comments. Someone over there wrote, oh, instead of using Maven, just use Gradle. In a way, yes. I mean, in case of dependency resolution, Gradle is aware of semantic versioning from the core. You don't need an additional plugin to make it happen. But if your build is already Maven, migrating to Gradle is a one-way thing. And you have to eat the whole elephant. You don't have a try me version. You have to do the full migration in order to really reap the benefits. Some people can do this easily and in timely fashion, and for some others, the cost of doing a full migration is prohibited. So, if you're using Maven, is it recommended to try Gradle? It depends on the size of your team, on the time to market. There are many different reasons. But at the very least, I would certainly recommend you to build a proof of concept in case that you have tried many things to solve Maven dependency hell, and still Maven doesn't give you the answers that you want. The other reason why it's important to look at these things is that all these questions actually happen in production. These are not theoreticals. This actually has happened in the past, and most likely has happened to you at some point. It is necessary, it's required to understand why the Maven POM file works in this way, even if you use Gradle. Why? Because the dependencies that you're consuming, Spring Boot, Quarkus, all those things, it's a combination of both Maven and Gradle produce. The POM files written by Gradle work differently as the POM files written by Maven, because Gradle doesn't care about dependency management block. Gradle doesn't care about certain things that Maven files will have explicitly. So the way that you fix a problem requires you to talk to the creators of the library and tell them, could you change your POM file in this way or this other way so that my life as a consumer will become easier? If they're using Gradle, they will have to use different techniques to produce a POM file. If they're using Maven, they will have to use a different set of techniques to produce the POM files. And if it's you, the ones that are producing POM files, because maybe you're maintaining libraries within your organization, then now you have to know how to fix these particular issues.
So there is a lot of things that we can talk about Maven, because we didn't even touch Reactor. We didn't talk like how to create POMs, like flatten all the dependencies. So when we are publishing libraries, we are not giving our consumers the same problem. So Maven, it's really one of the most powerful tools, the most used tools out there. And we actually need to know at least where the monsters are. And I think now you have more compelling reasons to start using the Maven Enforcer plugin, or at least know that the position of your entries in your POM XML does matter and can give you headaches.
Right. So again, Maven is quite popular. More than 70% of people use it as a main build tool. And many of us, including myself, at some point I said, XML. How difficult could it be, right? Well, it turns out there are some rules that are not necessarily laid out or explicitly written in documentation that you have to be aware of in order to make the most of Maven. So, like any other tool, whether it's Maven, Gradle, Eclipse, IntelliJ, whatever, what have you, take some time to really understand and learn how to use the tool. So I'm not going to say, use tool X or tool Y. Use the one that you're currently using, that's perfect. But just take a little bit more extra time to get a little bit further and learn it to be more effective with it.
Well, thank you very much. And if you have more questions, we are going to be around. Thank you.
Thank you, JNation.